once the CBR collects the data, it puts it onto the calculator, and this is a screenshot of what the calculator gives us. This is showing where the ball started at the top, and every time it hits the ground and comes back up. Hits the ground and comes back up. So we have what we call the rebound height is what we're going to look at. So we have the top of the graph here is where the ball started. Then it rebounded to this height, to this height, to this height, this height, and this height. And it continues going, but it just couldn't read it anymore based on the height. So what we're going to do is we're going to record these heights into our handout that was given to us. So we have our rebound number. 0 represents the y-intercept of the graph. It's the initial height, so where the ball began. And then we have a height for each rebound 1 through 5. We'll be doing some calculations also. But to actually determine the rebound height, we want to actually use our graph. So I've marked on this graph where the ball was at the top. And then I've used the trace feature on our calculator with some more screenshots to find the height. So we have, these are our heights at each one. Third height, and all the way to our last height. So those are what we're going to record in our chart, the handout that was given to us by the teacher. So in our chart, we've listed the heights that were from the rebound of the ball. So now what we want to do is we want to find the rebound ratio. And to find the rebound ratio, we're going to take the second rebound height and divide it by the first for each one, and that's going to give us our ratio. So on our calculator, we will do the second 0.629 divided by 0.862. So that is going to be 0.73, and we're going to do that for each of our rebounds. Now that we've found each of these, to find an actual rebound height for our function, which will be called R for our explicit formula, we will average these values. So when we average our values, our rebound ratio overall is 0.726, and we'll use that to actually find our explicit model in just a few minutes.